so much again for having us. Very, very excited to be here and be able to share with you some of the applications of data science at M&S. So first of all, a little bit about your speakers today. My name is Martyna Jones. I have been working with M&S for just over 3 years. Initially, I worked in an analytics role within supply chain logistics, but over time, I've transitioned into a data science role, and I'm working on what we call the enterprise data science side. So working on improvements to our internal decision-making and applications of data science, that internal decision-making within the business. Specifically myself, I'm working on a markdown pricing optimization problem. The talk, which is happening in the live session on Saturday next week, is actually about that specific application. So if you can come along, do so. Together with me, I have got Mohammed, who's a senior data scientist, also on the enterprise data science side, and Darren, who is a data scientist on the digital experience, so customer-facing data science. So we will be talking today about 2 different data science applications at M&S, which are both related to connecting our customers to our fantastic products and making the most of every sale opportunity that we have. But before we get into the technical nitty-gritty, let's just talk a little bit about the business. Let me give you a short introduction, both to Marks and Spencer's and data science at M&S as well. So for those of you who are based in the UK, M&S probably doesn't need too much of an introduction. We are a leading British retailer, and we supply food, clothing, and homeware products to the customers in the UK, but also internationally. As David mentioned, we have been established in 1884, so we've got a nearly 140-year heritage behind our belt. You can imagine with that comes some unique challenges, but also a very, very unique experience that we have in the business. On a yearly basis, we report nearly 9 billion revenue, which places us firmly among some of the biggest companies in the UK. We are incredibly proud of our large store estate. We've got over 1,500 stores across the world. And this is of varying shapes and sizes, a varying format of stores, from large multi-story locations, such as our flagship location in Marble Arch, to smaller locations such as petrol stations or railway stations. So a lot of diversity there already. We also, as I mentioned, have a significant international presence. We are currently in 100 international markets, both physically and online. And with that size, reach, and history comes a lot of complexity in our data, in our operations, in our supply chain logistics, in our decision-making, and in all of that tying together. What is quite unique and interesting about M&S is that there are 2 sides of the business. They are not completely separate, but there are 2 distinct sides of the business. We've got the foods business, where we are very proud of our quality, freshness, innovation, some of those credentials. And again, for those of you in the UK, you'll be very familiar with our popular Percy Pig sweets. We sell 10 of those every second, which blows my mind. I'm personally also Team Colin, if you ask me, just to put it out there early. On clothing and home side, we are very proud of a contemporary wearable style, which comes at a great value. And we are market leader in several areas. Amongst others, 1 in 3 bras in the UK come from M&S. So what is important to understand about M&S is that we are a business undergoing significant change. I spoke about this nearly 140-year history. We need to stay relevant. We need to keep transforming and changing to stay relevant to our customers. So even before the pandemic, the business has been really working hard to reshape the way we operate, update our store estate, and provide new, great, modern, sustainable offer to our customers. So some of the highlights of our transformation, first of all, you see Percy there, 50% investment in Ocado retail, so actually reaching our customers with home deliveries. And at the moment, we are reaching a 25% basket penetration on Ocado, so great success. We've accelerated the rotation and renewal of our store estate. In the middle picture there, our beautiful renewal store in Clapham, which is looking nice and fresh and tidy. We have really sharpened our focus on Plan A, and some of the campaigns that we're proud of include the look behind the label, where we focus on ingredients, sourcing, as well as swapping, where customers can donate unwanted items for recycling in exchange for vouchers. Now, through the pandemic, as many businesses, our transformation has been accelerated, and we have really seen an omni-channel business emerging, in particular on clothing and home side. At the moment, in 2020, over 50% of our clothing and home UK sales happened online, which is a huge acceleration. And with that, we've seen some really great examples of cross-channel customer experience. So, for example, the banner you see at the bottom is an example of virtual consultations for furniture shoppers, which we were running on furniture initially, but we're looking to roll this out to other areas of the business. And then finally, last year has seen us relaunch our loyalty program called Sparks, which provides our customers with tailor-made offers and treats as they shop with us. So the common theme throughout this whole transformation has been that of becoming digital first. And of course, data science plays a huge role in that. So a little bit about data science at M&S and the way we work. We work across both customer-facing as well as internal business, or we call it enterprise domain. On the customer side, we focus on three main areas. So loyalty, this is, for example, those tailor-made Sparks offers I've mentioned just a minute ago. One-to-one marketing, where we work to personalize the content of marketing emails so that it's always relevant to our customers. And digital experience across both web and app, for example, powering our product recommendation engines. On the enterprise side, in retail, so store operations, we help accelerate and enhance decision-making, for example, around labor planning. Clothing and home, we do quite a lot of work around pricing our products, both during the in-season trade, so live product promotions and the pricing there, as well as when the product comes to the end of its life cycle and goes into a sale. And then in food, we're working on optimizing our ranges to maximize sales and avoid waste. In all of those areas and across all of those areas, we work in broad cross-functional teams. Usually and typically how this will look, we are a team centered around a common mission, we call it, which will have a number of associated business problems. So for example, a type of a mission may be loyalty, and there'll be a number of business problems to solve underneath that. And we aim to solve those business problems with a data product. So the team typically will consist of quite a large number of different team members. So this will be business stakeholders, business SMEs with that business knowledge. We have got product managers who take care of the overall data product management. And then on the technical side, we'll have a data scientist supported by our MLOps team, as well as data engineers and data analysts. And just to highlight a couple of examples of the tech stack we work across, you'll see that we code predominantly in Python. We've got a very strong partnership with Databricks. So we work very, very closely in and with Databricks. We utilize a number of Microsoft Azure services. So this is machine learning, DevOps, as well as Data Factory. We are increasingly making use of some of the data cataloging and data quality tools available. So Lahr, our data catalog, and recently launched Atacama, which is a data quality tool. If you don't know it, check it out. Really, really useful, especially across a really large organization such as ours and the volume and scope of data that we have. And then we have got a number of different data visualization solutions that we utilize. In particular, Power BI is the one which is embedded in our environment and within the business very, very strongly. So enough about us. Let me just introduce you to the theme of the talks today before I hand over to the first speaker. So today we are going to talk about across a common theme of making sure that our clothing and home customers really get to see the product that they're most interested in. So connecting our customers and the product. And this is in two slightly different ways of understanding this problem statement. First of all, making sure that the product is available for our customers to shop, whether you go and shop either in store or online. So making sure that we've got the right mix of product at the store where the customer wants to purchase it. And also across online product recommendations. So this is connecting the customer to the product in the sense of recommending the product that they may be interested in. So without further ado, I am going to hand you over to the first speaker, Mohammed, who's going to talk about his work on size level forecasting. Mohammed, over to you.
Great, thanks a lot, Martyna. Good evening, everyone. Hopefully you can see my slides. It's a pleasure to be speaking here tonight and contributing to the Online Data Science Festival. So for the next 20 minutes or so, I'll be talking about a POC project I've been working on. So I joined M&S just at the start of this year. Initially, I was working on a food project, looking at optimizing the range of products we send to food stores with the idea of trying to minimize food waste. And since then, I've been looking into working in our clothing and home team, so looking specifically on clothing products and trying to work on our sizing problem. So ensuring that our customers get the right size mix of products they want in their store and having the right availability. So initially for this next 20 minutes or so, I'll go through an introduction, explain what we define as a critical path of a product at M&S, and then give some context to the sort of business problem we were looking at tackling within sizing. And then the next part of the talk, I'll be focusing more on the actual data science solution, the POC that we started looking at and currently trialing. So this schematic really shows all the key phases that happen in a critical path of a product at M&S. So typically we start with a planning phase. This is where our financial team and our merchandisers set up a financial plan and create a budget for the upcoming season, which is typically 6 months. And within that phase, they'll plan how many products we're going to buy and what the sort of focus will be. And then that's taken care of next by the designers. So they start to look at actual design of these new products we're going to start selling in the upcoming season. And this process is typically done mostly digitally. So it's a sort of iterative process between designers developing the product and the merchandisers, seeing how it shapes up before sort of approving that product. And then once teams are all happy with the products, we'll actually start buying the product. And then it can be a fairly long lead time after that to actually manufacture and start shipping the product to our distribution centers. And then once the product arrives in our distribution centers, typically about a month out, we can then start allocating to all our stores and also start selling online. So within that, just want to highlight a couple of key phases and also add a bit more context on timescales. So initially we have this planning and buying phase, which could be quite far out from when we're selling the products, about 40, 30 weeks out. And then once that's all agreed and we actually, excuse me, actually start buying the product, we're about 4 weeks out from actually allocating to stores. And then after that phase, we start selling, which could take typically for sort of a new product, maybe about 12 weeks before it ends up in what we call markdown. So this is when the product goes on sale. And at each of these phases, when we think of it from a sort of data science perspective, we need to think about the timescales and also what sort of data is available at these time points to actually develop any models or contribute to the business in these areas. So within the planning and buying, which is quite early out, we would have, for example, CAD designs of our products. And then when we get closer to selling, so this move phase or allocation phase, we would have the actual images of our products. So they've actually physically arrived and we can take real images, which is quite useful in our modeling, which I'll talk about a bit more later. And then finally, within markdown or actual selling, you will have the actual sales information on new products. So you could sort of inform models in a different way than you might be able to in the move or the buying phases. In terms of the sort of problem we're looking at in general for retail and then specifically to sizing. So here we've got statistics from an IHL study. It's a little bit dated from 2015, but they look at what are the sort of the biggest revenue losses for retailers. And they reported retailers having out of stocks can cost annually over 400 billion. And then overstocking can contribute to about 300 billion. So really large problem spaces. In terms of out of stock, this of course could be very frustrating to a customer if they go to the store, they can't find their product. And then that could potentially lead to a lost sale. Within what we call a lost sale, there's another study which actually looked at what actually would happen if a customer goes to a store and doesn't find the product. So in maybe 9% of the cases, the customer just wouldn't purchase an item. So that is truly a lost sale and lost revenue for the retailer. In another case, that 15% maybe customers will just delay the purchase. So they will eventually spend that money later down in the line, further down. And then maybe 31% will buy the product at another store. So this could be lost revenue if that goes to another retailer, or it could be still revenue you could recover, excuse me, revenue you could recover from selling on your website or selling in another store, for example. So we focused quite a lot of our value analysis on what was the lost sales specific to M&S in 2019. And we wanted to also see what is it in a size, being size specific. So not just the product we bought, we didn't buy enough of, but actually how much of it is due to the sizes that we bought within that product. And to look at the overstocking as well, we did some analysis around the markdown. So when the product goes to sale, how much of that goes to sale and in certain sizes as well. So initially on the left here, I've got the sort of lost sales analysis for 2019. The total lost sales is really looking at what was the average rate of sale of a product in a store and how many weeks was that product out of stock to compute an estimate of what could have been those lost sales. And that's just looking at all potential lost sales as a whole. We then, to make it size specific, we take a particular product, maybe a pair of jeans. If that comes in 10 sizes, we first look at having at least 5 of those sizes in stock before we count lost sales on the remaining 5. So then we're trying to look at the lost sales being more size specific and not just the product as a whole running out of stock. And then we had a third measure to be even more stringent, which is looking at having 8 of those 10 sizes in stock before counting lost sales on the other 2 sizes. And what we see here for the whole of 2019 from our clothing, 57% of all the lost sales potentially we could have had were actually size specific. So this is where you had at least half of your sizes in stock and the lost sales are focused on the other size. And this also shows a similar image, but only looking at a specific product here. So we have this shirt and we looked at what the lost sales were for the different sizes. So this came in sizes 6 all the way up to 24. In the middle here is what we sort of define as core sizes, the ones that most customers might purchase. And the sizes on the extreme ends, which are extremely small or extremely large, we refer to as fringe sizes. And overlaying that here, we've got the actual selling ratio and the buying size ratio that we had of this particular product. So with the core sizes in the middle, we can see our buying ratio was a little bit lower than the actual selling ratio. And then we see the reverse when we're looking at our fringe sizes. And then when we look at the actual markdown for this particular product, we see the flip of that. So we see the markdown is actually concentrated more on these fringe sizes and less so on the core sizes. And given the difference between the sort of buying and selling ratio, what that's telling us is we are probably buying more of these fringe sizes than our demand warrants and what we're selling. And the opposite for our core sizes. So we actually need to buy more of those to sort of meet the sales demand. And given what we've seen in terms of lost sales, what we wanted to check is if we try to just optimize the allocation of where we send stock to our stores, how much of these lost sales could we potentially recover? So we looked at how much stock was left over at the end of a season. And then for those particular products where we had stock left over going into markdown, we also compared them to their lost sales in other stores. So in this case, we're looking at a particular pair of jeans, maybe didn't sell in one store, but it actually ran out of stock in another store. So we're trying to see, had we optimized how we allocated those sizes and products, could we have recovered some of those lost sales? And it turns out we could have potentially recovered just over a half of those lost sales by better allocating our products. So we see that from this, there is an opportunity in sort of improving the size mix we send to stores. And also particularly we think for new products, which I'll go into explain a little bit more in a second. So going back to this kind of schematic of our key phases, we chose to really focus on this move or allocation phase. The first reason being it's only 4 weeks out from when you sell a product. So we are focused as a business on delivering value as quickly as possible. So wanted to develop a solution that we could start adding to the business and adding value. And at the same time, it looks like we can solve a big part of the problem space, just over 50% of our lost sales, just by improving how we allocate the sizes to stores. So this move or allocation phase has a couple of key components where we could look at applying data science to improve that allocation. At the highest level, it's what we call our product sales estimate. So this is just estimating for the whole of retail or our online business, how much we think we'd sell of a particular product. That's just a forecast that at the moment comes from our merchandisers who plan how much they think we can sell. And then going one step more granular, we can look at the actual store percentages. So we currently model for every store how much we think it will actually sell out of the overall product that we bought. And then finally, the most granular level is then to look at what is the size mix to use for every store and product. So as this was a POC to add value as quickly as possible, we started first tackling this most granular or lowest level in the problem space. So we're looking at recommending sales ratios for different sizes. And currently at M&S, we do have a tool, our size ratio tool, which actually recommends what size mix to send of products. This works quite well on what we refer to as regular sellers, so things that a typical pair of jeans that we'd sell all year round, year on year. So because it has so much sales history on these products, it's quite good to actually, it's quite good at being able to predict how much you'll need in what size. So, but on the other hand, at M&S, we actually sell maybe more than 2/3 of our products are new fashion products. So these are just one-off new items we'll sell every season. And for these products, we don't actually have any sales history. So this is where we think our size ratio tool could sort of be supported. And this is what we sort of targeted for a data science model. So it's looking at new fashion products and recommending what the size mix should be when we start to allocate those products. So just to crystallize that, we're looking at within women's wear, for example, size 6 up to 24. What we want to do is recommend the right size ratio for how this product will actually perform. And when we were looking at this, there were a couple of different potential modeling strategies to achieve the end goal, which is these size ratios. The first thing we looked at was actually just doing sales forecasting, but this was quite granular. So we're looking at a store and a size level. When that comes to clothing, that can mean very low frequency of sales. And so with the intermittent demand, it can be quite challenging to model at this level. But the initial idea was to model at that level and then roll up those forecasts to produce an actual sales ratio. So for example, this may have worked quite well on our .com business where we had a high frequency of sales, but it needed improvement when we're looking at our retail and our store level. So rather than forecast the actual sales, what we looked at was using a model to predict the actual sales ratio directly. And this actually did show better results. So I'm going to explain that model in more detail. So in the second part of the talk, I'll go through this sort of data science solution we looked at. Within that, the first part is talking about store clustering. So we did look at recommending size ratios, but not at individual store level. We're actually looking at a cluster of stores. And then I'll talk more about this sort of data we were using. So we have this feature repository at M&S called our product feature repository, which is a great store of different data points you can use on products. And then I'll talk about the actual light GBM model we used and how we tuned that. And then I'll also talk about how we actually backtest this model. So it's great you can look at your own training and test set and see your score of your model, but it's really useful if you can actually backtest and compare to something the business currently uses, and in terms of, in our case, the size ratios, and to see if we were more accurate than what the business currently use. And as that looked positive, I'll then talk about the sort of live trial we used and also next steps in terms of how this can scale up into a more comprehensive solution for allocation. So we looked at store clustering rather than recommending a size ratio for every individual store. And really rationale for that is we don't think every individual store warrants its own size curve. There may be a group of stores which have similar sort of customer demographics, similar sort of location, and they're likely to see a similar demand in terms of size curve that they would exhibit. And then secondly, also, as I mentioned before, the intermittent sales that you can have do make it quite challenging to model at a store level. So we wanted to actually work on a store cluster level. And within M&S, the team that have developed our size ratio tool did also have a k-means clustering model, a relatively simple one, but quite effective. It looks at historic sales of products at a particular department level, and it clusters in terms of the historic sales, so clusters the stores together. And when we talk about department here, we're talking about a sort of aggregation of our products in different levels of our hierarchy. So it could be something like casual tops or knitwear. In this image here, the example I'm showing, it's actually one of our schoolwear departments. And it shows quite an interesting location divide in the three clusters. So you've got in the south, quite a big cluster of stores there, which tended to have a higher size ratio, a larger size ratio rather. So the size curve is shifted more to larger sizes. And then as you go up to the north, there was a cluster there sort of closer to Scotland where the size ratio was actually more shifted to smaller sizes. And so, yeah, we basically, as this was a POC to quickly develop a solution, we just inherited this model and used it as a starting point and an input to our model in terms of what store clusters we're going to be predicting sales ratios for. Secondly, we looked at actual product images. So as I mentioned briefly, we are looking at forecasting the sales ratio of brand new products that we've never sold before. But to do this, we're trying to match it to historic products we've sold that are similar. So if we use the product images, we can extract quite a lot of useful information in terms of the shape, style, the color of a product that we've sold historically, and try to learn from that what the new product might actually do in terms of its sales ratio. So we took our sort of color images and also grayscale versions of those. And then we basically just applied the transfer learning on that. So we took a pre-trained DenseNet model to create our feature embeddings from these images. This is a really great way to get started really with computer vision without having to train your own deep learning model. It's not necessarily developed specific to our clothing products, but we saw that it worked fairly well as a starting point. So this creates the feature embeddings on our products. We then, just as a sense check to see how good that was, we took those feature embeddings and plotted a TSNE representation of that. And then what we saw instantly here was we actually had a cluster of pictures here where we actually had the model in the image, whereas in the rest there weren't actually any model photos. So clearly the embedding did show that it was working fairly well. In addition to that, we also look at what we call our swatch images. So these are close-ups of the actual product, showing particularly just focusing on what the color actually looks like. And then we actually cluster those images to extract the most dominant color. And then we apply a conversion to go from the sort of red, green, blue value to an actual lab color. This is supposed to be something closer to what a person might perceive in terms of the color when they see it on a screen. And then finally, we also looked at our sort of text descriptions that we have on the website for particular products. So in a similar fashion to the images, we use the Spacey Universal Sentence Decoder, which is a pre-trained NLP model. We sort of ran all descriptions through that to get also feature embeddings from our text data. And just as a side note, this was all packaged together in the M&S team as a product feature repository. So this was something set up to support multiple data science use cases. And in my particular POC, I was very lucky to have this in place to very quickly get to the sort of modeling phase. So in terms of overall features, look at the numerical features we used in our model. The first one, as I mentioned, was all the embeddings from the images and the descriptions. But those are, of course, very highly dimensional, which we couldn't really use in their full form, in their raw form. So we applied a PCA to those to compress those features. And here's just a plot of the number of principal components and the actual variance you capture, going from your top principal component all the way down to the first 300 in this case. What we found with the first 100 principal components, we can capture 70% of the variance of the data. So it was quite encouraging, and that's what we settled on for this initial model. And then secondly, I was also looking at the sort of year or week of year as a feature. This was particularly a focus when I was looking at actual sales forecasting, but still kept it in as it showed some relevance even to the sales ratios, although the ratio of sizes may not be as sensitive to the time of year as an actual sales forecast. And then from that, we also extracted the sine and cosine of the week of the year. just so the model, it's more clear to the model that week 52 is as close to week 1 as week 2 is to week 1, rather than just representing it as week 1 to 52. And then we also, of course, one of the main features really is the size itself. So that was encoded as an ordinal variable, going from size 6 to 24. And then we also engineered this size squared feature to try and represent the fact that our fringe sizes are actually closer together than our core sizes. So by taking the square, we map our fringe size 6 and 24, for example, to -80. And then the core sizes, which we expect to behave more similarly in terms of the actual sales ratio, then they're closer together with that feature. And of course, we included the product price as well as a feature. In terms of our categorical features, as I said at the beginning, we were using store clusters. So these came from our k-means model and was set at 3 clusters for every department. We also had a categorical feature, which is just a basic product type description of what our products are. So whether it's a casual shirt or a coat, for example. And we also have a feature which defines if our products are regular sellers or they're the new fashion type products. That was also added to the model. And in terms of the target that we're training our model with, this is the actual historic selling ratio. So just to make it clearer, for example, we're looking at a store cluster 1 here. This might contain 50 stores. And if the product comes in size 10 to 16, then what we want to be able to predict is that sales ratio, which should add up to 1. And as this was based on our sort of allocation, we were just focusing on what that sales ratio is in the first 28 days of sale for a new product. So this, all these inputs were put into a light GBM gradient boosted model, and we're treating the data in a sort of time series sort of fashion. So for our HighParameter tuning, we were looking at 3 different data sets with respect to time. So taking roughly 24 months of data, excluding the sort of COVID period where we had major store closures. And then our test set was a particular month, or validation set was a particular month where we start to launch new products. And then we increment that by 1 month at a time to have 3 sets overall. So we have our cross-validation and perform our HighParameter tuning. I've got a list here of the different things I tested out, a few interesting things to call out. When we were first looking at actual sales forecasting, we did test out the tweedy loss function, unlike GBM, and that actually worked quite well in the case of having a lot of actual zeros in the actual target. So it's very sparse data because the sales were quite infrequent at a store level. But then when we looked at just modeling directly the ratios themselves, then the MSE regular regression loss function worked better. And in general, we actually were able to use HighParameters where we're increasing the complexity in our model. So we might have been growing deeper trees and also larger number of trees as well to achieve that sort of result from our boosting model without ending up in overfitting. So having done all that, we then wanted to backtest this model and see how good is it versus what the business currently use. So this was really important before we make a decision on actually trialing with this product. So what we did really, as normal, we calculate our regression metrics on the sales ratios. So using the mean absolute error and the root mean squared error from our model against our validation sets. So we're looking at 3 launches, July, August, and September of this year. We compute those errors, and then we also take what the business currently use for their own sales ratio, compared it to the actual again, and then calculate the error for their own version of those sales ratios. And then we calculate a percentage reduction in the error using our model versus what the business were using. And what we found on average, we're reducing in terms of root mean squared error by about 5% compared to what the business were using, and 8% reduction on the mean absolute error. So this was quite encouraging for our POC and something we were keen to actually start trialing in a small scale in a real A/B test in our stores. So we've got a current trial running at the moment using roughly 180 stores split between test and control. As we were looking at sort of a November trial, we are limited month on month in terms of how many products are actually launching, new products. So we did do a power calculation to see what kind of uplift in our metric we were able to measure. So the metric we were looking at really is just the sell through. So this is looking at the total sales divided by the amount of stock received in a store. And we were looking at that at a product level, so not just for individual sizes. So taking an average for a whole product at a store, what is its sell through, and then comparing it between our trial and control group. And then we calculate this sample size to see what kind of uplift we can get. And based on the samples we have, we're looking at a sort of 2% uplift, which is quite ambitious. And we might not necessarily see that in this small trial, but it's good to know for future launches, which might be bigger, what we need to sort of target. And in addition to that, we also wanted to see how good are the sales ratios in making the sell-through more even across sizes. So in this example here, we're looking at sizes 6 to 24, where the sell-through of size 6 might be a bit lower than the other sizes. But if you end up sending less stock of size 6 to a particular store, then that will increase that sell-through. So what we'd like to see is a more even sell-through across all of those sizes. So another metric we're also following is looking at the average difference between all of the sizes. And what we'd hope to see is that our trial group will actually have a smaller overall difference, so meaning it's more even than the test group, the control group, sorry. There's just some final thoughts on where this could sort of go next. So we're looking at within, as I said, the move allocation space. So first, we're just looking at the sales ratio of sizes. That's the most granular level to look at. The next level up would be actually trying to model what our store participation should be. So we currently have this at MNS, but there's a space for data science potentially to model something there. So this will actually specify what quantity of product goes to a store, as well as what the mix of different sizes will be, if we were to look at that. And then the next level above would be the actual forecasting of our products and how much we think will actually sell overall for retail. If we have that, then we can combine all three models to actually get an actual forecast at a store and a size level. And then having got that, we can actually use that and input it into an optimization model to really fully optimize how much we send to stores. And as part of that, we could recommend what certain sizes we might want to remove from a store. So for example, we might see in some stores, certain very fringe sizes don't sell at all. So we might not want to send those at all. So we could use an optimization tool to really recommend how you range and how much we send to different stores. And for this initial model, we're just looking at simple sizing, which we basically refer to as like a t-shirt, just has one dimension to its size. But this can also expand to complex sizing, where you might have trousers with different lengths as a secondary size. And we're initially looking at our women's wear department. So if these results look good, we could also expand and look at other business units as well. So just to sort of wrap up the main sort of key points from this, we saw that 57% of lost sales in 2019 were actually size specific. So the sizing aspect to that was quite a big part of it. And out of those lost sales, we could have potentially recovered over half of those had we optimized the stock we sent to certain stores. So we do see a lot of stock gets trapped in certain stores, goes into sale in markdown, while that same product goes out of stock in another store. So there's clearly an opportunity to optimize how we send those products. In terms of the solution, so we were able to recommend here size ratios for brand new products that we never sold before by using the right data from historic products and looking at how similar they are. And we used this slight GBM gradient boosted model that resulted in a 5% improvement versus what the business currently use. And this modeling of just the size ratios could later be combined with other models to actually look at our forecasting overall and be able to optimize properly where we send products. And just the last point really is just to highlight again the fact that at MNS, we have this feature repository that was put together with a collection of sort of the product images and features of those, which really helps to accelerate the development of any future models that the team might be working on. And it's a great way to reuse the work that a particular team is doing as well. So I believe we'll go through Q&A at the end. So with that, I'll now hand over to Darren.
Cool. Thanks, Mohammed. Just share my screen. Cool. So evening all. In this 20-minute presentation, I'm going to be talking about online product recommendations. Namely, I'm going to be going through two models which are currently live and serving recommendations to our customers on both the website and mobile apps. So to begin with, I'm first going to give a bit of background to the team. I'll then move on to talk about our similar items model, before then talking about outfit generation model. So if you go to a product page on the M&S site, say, for example, you visit this shirt, if you scroll down, you'll see three carousels. First, you'll see style it with, you'll also see you may also like, and why not try. Style it with is our carousel pertaining to outfits. So the aim of this is to recommend other items of clothing that a customer might want to buy. So in this case, you're looking at this shirt. What other clothing items might you want to wear simultaneously? The you may also like is about showing the customer different shirts they might not be interested in. And the why not try is all about cross-sell. So just predicting items that the customer might want to buy, regardless of, say, any restrictions. So for team overview, our main focus of the recommendations team is for online, so website and apps, and we mainly focus on clothing and home. We're a multidisciplinary team, so we comprise of data scientists, data and software engineers, front-end developers, and many other roles. And we're quite a new team, so we're formed in mid-2020. And there are currently 2 data scientists in the team, including myself, and there's a vacancy for 1 more. So if you're interested, please apply. So to give you a sense of scale as to why these recommendations are quite important, it's key to note that over 50% of clothing and home sales are now online. And across all our apps, and including the website on desktop, we get over 10 million page views a day. And 25% of these are to page views, so PDP pages. And what this kind of gives us is the opportunity. So we've got over 2.5 million opportunities to display to your customers some of our carousels, so some of the recommendations, which I just mentioned to you on the previous slide. So first off, I'm going to talk about the you may also like carousel, so similar items. So just to remind you, you've gone to some trousers, and you scroll down and you want to provide recommendations of other trousers that you might be interested in. So to kind of summarize how that model works is we use matrix factorization with a warp loss. But before I go into that in more detail, it's quite important that I talk about the different types of data that we have at M&S. So we've got both explicit and implicit data. So explicit data is essentially where a customer tells us how much they like or dislike an item. So this could be in the form of, say, a product review. So somebody could leave a 1-star review on a pair of jeans or a 5-star review. Implicit data, on the other hand, is where you can kind of infer how much a customer likes or dislikes maybe a product from just how they interact with the website. So you can kind of infer that maybe a customer likes a product through them purchasing it, or them clicking on various articles, or how long they've spent on a given product page. So maybe if, for example, somebody visited a given product page 5 times, that might indicate that they're quite interested in that product. Typically, we have a lot more implicit data than explicit data. So imagine YouTube, for example. You've got hundreds of millions of views, but maybe you've only got a fraction of people who've actually hit the like or dislike button. And one key distinction is that with implicit data, only positive interactions are observed. So to give a brief overview of what matrix factorization is, the goal is to approximate, say, this interaction matrix R as the product of 2 smaller matrices. So In our case, for this model, we use purchases as the data source. So what I've got here is for rows, you've got customers, for columns, you've got products, and a 1 here represents that this customer has purchased, say, this shirt. And nulls are typically filled with zeros, and how we find the weights of these matrices U and P, so the user matrix and the product matrix, is done by typically minimizing the squared loss. One thing to note with this is that kind of by filling with zeros, you could end up with issues in the sense that if you have a model with enough expressive enough power, your model would essentially predict zeros for any item that the customer hasn't purchased, and you would end up not being able to recommend or rank at all. And also this loss function kind of just directly optimizes for scoring single items in isolation. However, what we really want is kind of a ranked list. So we can actually do better, and this is where we use a Bayesian, where we can talk about Bayesian personalized ranking. So where we get a better loss function, more optimal to the problem at hand. So instead of directly optimizing for, so instead now we directly optimize for correctly ranking item pairs instead of scoring single items. So we kind of reframe the training data slightly. So we've got 3 key assumptions. So what we make the first assumption, which is that we assume that items that a user has interacted with are preferred over items that they have not. So as an example, if I've purchased a pair of jeans, we say that I prefer them over, say, a pair of socks that I haven't purchased at all. For a pair of items where the user hasn't interacted with both, we can make no assumption about preferences. So say, for example, I haven't purchased a shirt and a jacket. You can't really say which one I prefer. And similarly, if I've purchased 2 items, you can't really say which one I prefer over the other. So on the right-hand side of the screen here, you can see an example. So this customer has purchased both this white shirt and this black dress. And if I denote that for this customer U, that I greater than UJ essentially means the user U prefers item I over J, then you can kind of create this preference matrix here based on the assumptions that I just talked about. So here we can see that I put a plus here in I1, J2, which means that this customer prefers the shirt over the boots. And that makes sense because they bought the shirt and not the shoes over there. And in terms of now how we capture all this training data for this given customer, what we do is we take all the pluses here, and what that amounts to is just taking all combinations of positive items with negative items. So by positive, I mean things that they bought, and negative things that they haven't bought. And our goal, which will become clearer on the following slide, is to produce a score ZUI for each user item combination that defines a good ranking. So this is the output of our kind of matrix factorization model. And we want the score for an item that a customer has purchased to be higher than something that they haven't. So with BPR, the quantity that we try to maximize is given by this product here. And you can see that the probability that user U prefers item I over J is given by this kind of sigmoid function over here, which is 1 over 1 plus E to the ZUJ minus ZUI. And this quantity is maximized when ZUI is greater than ZUJ, which kind of ties into the point which I just mentioned on the previous slide. So that's at a high level how BPR works, but we can do even better. So at the start, I mentioned that we use a warp loss. So the warp loss itself is slightly different from BPR, but it also improves in another key way through the learning procedure. So with BPR, how it works is that you'd sample, in part of the training procedure, you'd sample a given user, a positive item, and a random negative item. So positive item being something they bought, negative item being something that they haven't bought. And what you do is you then calculate the gradients of the loss function and update the weights. However, with Warp, you do the same sampling, but you only actually update the gradients and the weights of the model if there is a violation. So that is if the item that the customer hasn't bought is greater than the one that they have. I'll explain that in greater detail in the next slide. So imagine we're partway through the training procedure, and as it currently stands, this customer here has bought these pair of jeans, and the output of the matrix factorization model is given below. So you've got 3.1 for the shirt, and for the item that they have purchased, the jeans, it's got an output of 2. So what happens is we sample we always have a positive item that we sample, and then we sample a random negative one. And in this case, the positive item scores higher than the negative item, so we resample. In this case, now that we've resampled, we now have the shirt appear, the white shirt, and it corresponds to a score of 3.1. So now we have got a violation. So we calculate the gradients of the loss function and then update our parameters accordingly. So yeah, to summarize, what we do is we train that matrix factorization with a warp loss over customer purchases over the last 360 days. So this gives us a user matrix and a product matrix. And what we do to create recommendations here is, if we wanted to now find what items to recommend for this pair of jeans here, we use the product matrix and use the cosine similarity. So we get the embeddings for this, and we'd use the cosine similarity to rank in descending order all the other pairs of trousers that they might be interested in. And to test this approach, what we did was we compared it to kind of one that we can use from Adobe. So they offer a lot of functionality for some of these pre-built models. And what we saw was a 4% increase in the carousel interaction rate of this model I just spoke about versus the Adobe target model. And we also saw a 14% increase in the add to basket rate of items discovered through the carousel. So what that means is, once I've clicked on, say, an item in the carousel, when we saw a 14% increase in those who went on to add the item to basket when we compared across Adobe and this model. So now moving on to style it with. So this is our the style it with carousel, and this is all around outfit generation. So just to remind you, the problem that we're trying to solve is customers viewing a pair of black jeans here, and we want to find out what items we should recommend that can be worn simultaneously with those jeans. So bit of definition: an outfit, what we refer to it, is a set of compatible clothing items that can be worn together. So kind of the problem we're trying to solve is when customers are shopping for clothes items, they don't often only want to buy one item. So now that I've found the shirt, for example, what jacket could be worn with it? Outfits, in our case, can consist of up to 6 items of clothing. And in terms of M&S, we currently have over 5,000 active women's wear clothing items on the site and 3,000 menswear. And around 70% of our products have no outfits. So for the 30% that do, often when a new product gets launched, a picture is taken of the model. So say, for example, we're selling a pair of jeans, a model shot is taken, and they might also be wearing an M&S shirt at the time. So that kind of gives us sometimes an outfit already, but we don't always have that. So the goal of this is to kind of plug the gaps. So we have 2 data sets that we have available to us. One's called the Try Tuesday dataset, and the other's called Shop the Look. So Try Tuesday is now a defunct service, but it was online a few years ago, and it was around free personal stylist advice. So what a customer would do is they would give a brief description about themselves, what type of clothing items they like. The stylist would then return a outfit that they recommend for them to wear, and they all consisted of M&S items. And in terms of shop the look, we have, as I just mentioned, the model shots. So whenever, for example, a new product is launched, we take a picture, they might be wearing 2 items of M&S clothing, they might be wearing 3. However, we have a lot less data on this. So in terms of how the model works, the model is essentially just a replica of what was described in the fashion outfit generator for e-commerce paper by ASOS. And the idea is to build a model that can distinguish between a stylist generated outfit and a randomly generated outfit. So it's kind of like a binary classification task. So for example, this is a positive outfit here on the top right and a negative outfit on the bottom left, on the bottom right. And the goal is for this model to predict kind of a 1 for this top row and a 0 for the bottom one. And at high level, how it works is each item of clothing is embedded into a style space such that compatible items of different categories are close to each other. And then pairwise dot products are then taken between the different articles or clothing to determine outfit compatibility. So as I mentioned, first of all, each item of clothing goes through an article embedding. And the goal of this is to get a vector, in our case, a 64-dimensional vector that represents this clothing item. And this, this uses the product feature repository that Mohammed spoke about earlier. So we take the color embeddings, the ecom embeddings and the ecom description. And what we then do is we feed this through various layers of a neural network to produce this vector of length 64. And once all of those items have been embedded, what we then do is we do the kind of pairwise dot products, and then we plug them into a Sigmoid function. So if you imagine for the moment that we've, say, got 3 different articles of clothing, what you do is you do the dot product between article 1 and 2, 1 and 3, 2 and 3. You then, that would represent your sum here. You then normalize by the number of products and feed it into the sigmoid, and that would give you a number between 0 and 1. And that's kind of the loss function. And in optimizing this loss function, we find the optimal weights for the article embedding, article embedding network, which I showed on the previous slide. So now that we've got a model, so kind of the outfit scorer, which allows us to tell whether or not an outfit is, say, generated at random or was done by a stylist, we use beam search to generate an outfit. So how you can kind of go through this with an example is, say we want to generate an outfit for these black pair of jeans here. What we do is we then look back at the historical data and see what stylists have done previously. So in this case, we've seen that stylists have previously matched jeans with shirts and a jacket. So now we know that for this problem, we need to find a shirt and a jacket, but we don't know which one. So what we first do is we plug in the jeans and all the different shirts into this outfit scorer, and then we obtain the output of the model. So we can see that, for example, this jeans and this black shirt over here get a compatibility score of 0.9, whereas with this striped one, it gets 0.93. And what we then do is we hold on to 5 of these, and then we iteratively kind of add in the jacket. And we kind of then move through. So sometimes the outfit template could be longer than 3, so we iteratively kind of move through. And at the end of it, for this example, we can see that the highest scoring branch was this top row here. So this is our outfit that we then take and put on the website. So in summary, the similar items model, which I spoke about at the start, uses matrix factorization with a warp loss on customer purchases. And product embeddings are then used to find similar items based on cosine similarity. And The outfit generator model leverages a neural network that predicts whether a set of products put together is at random or done by a stylist, and then beam search is used to generate outfits. And here are some of the references. So you can see here that the reference to the convolutional neural network used in PFR features, and some of the papers here which were used for both the outfit generation and the similar items model. I'm now going to hand back over to Martyna.
Thanks, Darren. Thanks very much. And let me just share my screen again real quick. Thank you both, really, really interesting. And just before we move on to the Q&A, a couple of real quick slides from us just to wrap everything up. So first of all, data science is a team sport, as we say, and we just wanted to say a couple of real quick thank yous to the other team members on our team for contributing to the two projects that we spoke about. So first of all, Matt Garrett, Andres Yaniku, Rhys Thompson, Chris Buxton, and Matteo Tomasetti. Thanks very much. We appreciate your hard work. Second of all, just to advertise again, Emma Walker, who is one of our colleagues, will be talking at the live event. She will be describing another data science application at M&S, which is all to do with pricing for a sale or markdown period. So come in if you're coming to the live session. This will be real interesting, and I'll give you yet another angle at how we're using data science at M&S. And then last but not least, it wouldn't be a data science festival talk if we didn't say that we're hiring. The QR code at the bottom of your screen will take you directly to the data science hiring or jobs careers page. So if you've got time to grab it and scan it, please do. It is a great time to join. Look, data science at M&S is really, really accelerating. I think we are a new team. We know that we're a new team, but that means there's a lot to go after in terms of the problem space. You've seen that we've got quite a versatile problem space we're working on across both the enterprise and the customer. And these are just two of the projects. I don't want to tell a lie, but I think it's 2 out of about 20 data science applications that we're actively working on at the moment. So really a lot of exciting opportunities to get involved, get stuck in across really a diverse subject area. So this is everything from us. I'm going to hand back over to David for the Q&A, and thanks very much for listening and dialing in.
Perfect. Thank you all very much. Darren and Mohammed, if I could ask you to jump back in, that'll be great. I'll maybe get you to, perfect, stop sharing that. Great shout out though. I've loved hearing about Marks and Spencer's. I've met quite a few of the team over the over the last 6 months or so, and everyone I've met from Marks and Spencer's has been fantastic. So I'm a big fan, so please do check out their careers page if you'd like to come and join them. In terms of now, we'll fire through a couple of questions. I've definitely got a couple myself. I can see a couple have come into the chat. If anyone does have any other questions, though, please do point them into the Q&A if you can. That would be super helpful. In terms of the first question, it's a question from Aidan actually, and it's more of a general question about data science at Marks and Spencer's. So first of all, Aidan said, thanks for the great talk so far. It sounds like you guys are a relatively new team. What are some of the challenges that you've come up against with that? What's it like working in a relatively new function at Marks and Spencer's?
Yeah, so I'll share a couple of thoughts, and then maybe you guys want to chip in as well. Yeah, look, we are definitely a very new function in I don't want to use the word old, but a legacy business, right? Mm-hmm. And it's a business that has done things in a certain way for a very, very long time. And we're coming in with data, sometimes disrupting that way of working. And there is challenge, and some areas more, some areas less, around that aspect and working with stakeholders. And actually, some stakeholders are all in for applications of data and getting stuck in and actually enhancing the decision making. In other areas, it may be a little bit more challenging. So what we do really need to bring into the table is rigorous proof of the results and the bottom line improvement for every single one of our projects. So that's something that is, it's work in progress, and we are working through that. And then I guess the second one is, again, big legacy organization comes with a lot of legacy data. We've got many systems. The data coming in from the systems is, well, first of all, messy and dirty. I'm not gonna lie here. But second of all, it takes time to find your way around it and navigate and understand. And for a new team, spun up really, really quickly. This is the reason why we are starting to use some of the cataloging and the data quality tools more and more and more to really get the time to proof of concept as short as possible and not spend a lot of time, trying to unpick what this data is telling us. So these are the kind of two from my side. I don't know if Mohammed or Darren would like to add anything.
Yeah, thanks, Martyna. Thanks for the question. Yeah, kind of covered what I was thinking, but just to briefly add to that as well, we are quite a new team, but also growing quite rapidly at the same time. So one challenge might be in a data science team, how you sort of standardize your ways of working and making sure everybody's working a similar way to productionize models. So we've got a great tech stack at M&S, but it can be used in very different ways. So at the moment, yeah, we're on that journey of trying to standardize the processes, how we write code, how we productionize it, and so on.
Perfect. Anything to add on that one, Darren?
We've covered it.
The guys have covered it. Love it. Talking there about the tech stack, actually, Mohammed, can you tell us a bit more about what that looks like at Marks and Spencer's? How you go about actually deploying the machine learning models as well, and actually also, if possible, a little bit how you work as teams. Are you working in squads, different data scientists integrated in different product teams and stuff like that? So yeah, it'd be good if we could get some context on that too, please.
Yeah, definitely. So our tech stack is based on the cloud and Azure primarily. So within that, we've got quite a lot of different tools, such as Databricks, where we do a lot of our data processing using PySpark. And then we also have got DevOps, where we do our sort of code versioning. And there's other good tools like Azure Data Factory, which is good at sort of orchestrating different things when you're productionizing your code. And there's also a tool in there called Azure Machine Learning Studio, which is a really great way of actually productionizing models and then creating endpoints to host those models from there as well. And in terms of how we actually work, it's very much a cross-functional sort of squad type of way of working. So we typically have a product owner who looks after sort of working with stakeholders, liaising, looking at sort of that side of it. And then we have data scientists, typically supported by a data engineer, as well as data analysts for various tasks. And then if needed, we also have an MLOps team to help with the sort of productionizing process as well. So yeah, very cross-functional team.
Perfect. Thanks very much, man. I find it super interesting, actually, hearing about all the companies organise their teams and also their tech stacks as well. There's a few more questions coming in, which I will get to. There is a couple of people that have still put questions into the chat. So I've seen a couple from Lakshmi, which look good questions, actually. But Lakshmi, if you can, please just drop it into the Q&A. That would be a great help. And then in terms of the chat, just to call out a few thank you messages as well. It's always nice to let you know that there are people out there. So Noor's been in, fantastic presentation, massive thanks. Andrew, great session, thanks for that. Danny, thanks to all, great presentation. Michael Bateman, thanks for the talk, very interesting. Sirish, great session, thanks. Rasim, again, thank you very much. So yeah, it's great to have those comments come in for the speakers. So thank you at home for commenting and let us know that you've enjoyed the session. So that is great. In terms of the Q&A, if you guys want to read along just at the same time as we're firing through them, that would be great. I'll maybe take that first question at the top there from Jojo. I'm really curious about the outcome of outfit generation. Did you see key business increases, sales added to the basket, etc.? So what was the business impact in terms of this project?
Okay, so there's kind of the reason why I didn't say put in the comparison metrics like I did for the similar items model was that there's nothing really that we had at our disposal to say provide us with an out-of-the-box outfit generation. So we couldn't just say use a black box Adobe model to say here's our outfit, here's some outfits, and then try and say beat it. So we did see positive results, but we didn't really have something to benchmark it against.
Okay.
If that makes sense.
Yeah, no, it does. Totally. Thank you. Let me click done on that. I'll organize my questions. I will take here we go. Have I just, I've clicked the wrong slide. I've got one job and I'm clicking questions are answered and they're not answered. So sorry, Noor, I've just moved your question into the answered column. So I will ask it still, don't worry. Noor's asking slide 47. He's a very organized man. He knows what he's talking about. So slide 47, model outfit generation. When you look to build an outfit with the specific black genes shown, does the recommendation engine only use the specific black genes shown, or does the engine use all similar black genes currently on sale, for example, other cuts and fabrics, etc.?
So kind of how it works is for every product that you see on the website, we want to, so clothing items, we want to generate an outfit around that. So if you go to a product page, you go on specific item of clothing, we generate an outfit. Even so, if you say black jeans A, we'd want an outfit, black jeans B, we'd want a separate outfit. So in relation to that question, we fix the first item because that's what we're building the outfit around, and then we generate around it. So that's actually held fixed. It's only the other products that we kind of try and discover through this model.
Okay, thank you very much. Thank you. Question at the top there from Sirish. For implicit data, what type of interactions can be negative other than examples of YouTube dislikes? What are some strong reasons for considering positive interactions alone? While for explicit data, I suppose you consider negative ones like low rankings as well. Does that make sense?
Yeah, I think I can try and attempt to answer this. So for implicit, so we have like so you've got like in YouTube ratings, you've got that kind of, that's like thumbs up would be explicit, where you kind of users told you they like or dislike. Another example of that might be, I think traditionally Netflix allowed you to rank stuff with a 1-star or 5-star rating, and you've clearly told you've clearly said what your preference is there. With kind of implicit, it's hard because what tends to happen is if you're, say, looking at clicks or like views that a person has done on a product page, you're looking at purchases, you can kind of make the assumption that if they viewed something or if they purchased it, they like it. But again, it might have been, the data is inherently noisy. So, but on the other hand, you don't really have negative examples because for items that say a customer hasn't purchased, have they not purchased it because they don't like it, or is it just because they haven't seen it? So there is this kind of whole noise with this implicit data in general, but kind of it makes up for it because we've got so much of it that you can build decent models.
Perfect. Thank you very much for that. I'm going to take this is more of a general question actually from Jojo at the top there. Talking, I think it's more around how we were talking about how the teams are structured and how you standardize deployment and all this sort of stuff. Jojo's dropping bombs in the Q&A here and basically saying, should we be standardizing? Does that block creativity? Should we just let different data scientists work in different ways? What are your thoughts on that one? Who would be best to pick up that question?
I could start and then the others want to chip in.
Cheers, man.
So yeah, when I was talking about standardizing, I was talking specifically in terms of how you go about productionizing a particular model. There's certainly huge scope for creativity on how you approach a model, how it's designed, and so on. And one of the good reasons for standardizing your ways of working, if somebody new joins the team and you need them to quickly pick up a new project, it'd be very easy for them to actually know where your code is. You have the same sort of structure of your template, of your code, and so on. It's very easy for someone new to pick that up and take that forward. But in terms of how you go about approaching a solution, yeah, there's absolutely tons of creativity and space for that.
Perfect. Makes a lot of sense. Does anyone else have anything to add, or is Mohammed?
Yeah, I'll chip in if I may. Just a little comment. It's a very good question, good challenge. I think 100% when we talk about standardization is about that productionization. And the reason for that is, sustainability of our solutions. I've come from a business analyst role effectively where we don't have any standardization in the business yet. And that leads to a massive legacy and a technical debt, which is being put in place. So again, putting a standard procedures now means that we can better, take care of that sustainability aspect, but also we talk a lot about making our solutions modular, then applying them into different use cases with some little modifications. But yeah, I agree completely with Mohammed when it comes to, the actual solution, it's entirely up to the data scientist what you do. Creativity is there and is encouraged.
Perfect. Yeah, makes a lot of sense, doesn't it? You have to have processes in place for some things, increase reliability, and actually makes everyone work more efficiently. But yeah, when the ideas come, get on the whiteboard and scribble some stuff down there. Perfect. Question at the top there from Suresh. I'll actually make it a little bit more general. That they were asking about, plans for the future. Has it been scaled out to different geographies, different data science? So, what are the plans for these models going forward? Are you planning to expand on them, use them in greater areas, different product ranges maybe? What are the plans for the future?
Yeah, for the sizing sort of model, so initially we're looking at just UK women's wear sort of department, and then based on the results of that, we might scale that particular solution up. So just looking at our sales ratios as it is, looking at more products like complex type of clothing. But then if we see that size ratios in themselves is not effective enough as a solution, we then go up to the next level, which is enhancing the model. So looking at actually what quantity does a store get. So that'll then influence more in terms of allocation. And the ultimate end goal is really to have that holistic optimization solution where we are optimizing how we allocate certain products and sizes to stores. Yeah, so this is still very early stages. It's POC, we're trialing, and we learn from that test and then decide what's the next step to take from there.
Perfect. Thanks very much. Sounds good. I'm going to actually shoot to the bottom of the list actually and take the question there from Michael, and obviously it's just had an upvote, so it's now second on the list, but it's the question from Michael. Michael's asking, how iterative is your optimization? If you beat a benchmark on a specific project, do you typically aim to optimize further in the same project, or do you typically move on to other projects?
I can take that. I can start off. So it really depends. So because we're a relatively new team, so if it's coming from recommendations, there's quite a lot of new stuff we can do. So for example, you always have this kind of competing view of, do we build something new versus improve on what we already have? And what we tend to do is we do scales of like, what's the business benefit, what's the customer impact, and then we could then kind of make a judgment call. So it really depends. Like, there's no hard rule, but I think as we expand out as a team, we'll start to, of course, focus more on, say, iterating what we already have.
Perfect. Yeah, sounds good. Thanks very much. We'll fire through these last couple of questions, but just as we're doing that, I will head back into the chat actually. So there's a comment there from Nidhi. It's definitely good insight on the journey. Start where to progress is now. Thank you for sharing. Jojo, thanks for the response on the creativity. So that one landed well with Jojo, which is great. And then Adnan, awesome presentation and information all. Great to see how Marks and Spencer's value analytics and invest in data people in a variety of roles. So thanks for those comments, everybody. In terms of these questions here, I've got another question here from Lahr. He's specifically talking about Atacama. I think you may have mentioned that in the tech stack, or I may have missed it, but he's asking, how are you using Atacama? Has it helped alleviate traditional data issues for you?
Yeah, so to be completely honest, Atacama brand new. We've literally just launched it 2-3 weeks ago, so we're just getting to know it and learning how to work with it. But let me talk about the kind of the problem statement which we're trying to address. We have got the same or very, very similar data coming from several disparate systems, and that data doesn't often agree. So you think, you know, a product data, information about a product, it should be just one source of truth. There may be variations. And we have got also a lot of data quality, missing data, late data, or dirty data as a kind of function of these legacy systems. So we're trying to use the tool to really highlight and quickly spot those issues and differences without, you know, somebody running into a problem and then flagging it somewhere on a Teams channel and an investigation taking forever to resolve it. You know, we need clean, good, well understood data to go into our models to, you know, train good performing models. So early days, but we're really hopeful that it will try and help us with some of those legacy data source issues. Hope that makes sense.
Perfect. Thanks very much. In terms of the questions now, question from Lakshmi, again, talking a bit more about the structure within the data teams at Marks and Spencer's. They're asking, in terms of that team structure, what other data roles are within the teams? Do you have a big team of data analysts, BI engineers, you know, visualization, you know, specialists and stuff like that? What are the wider roles within Marks and Spencer's?
One of you guys want to go, or should I take this one?
Come on, Martyna.
I'll take this one. Yeah. Right, so a huge variety of data roles. First of all, a dedicated MLOps team, which we work very, very closely with as data scientists, and a dedicated central analytics team. So this is business analysts, visualization specialists, but also each of the, we call them business units, so, you know, the sides of the business and the areas of the business tend to have their own analytics teams as well. So we work quite closely with those area specific analysts, let's say in supply chain logistics, with the central analytics team and, you know, MLOps and data science working together. So there's a huge variety. And when we do advertise, you know, data science roles, there is also a wealth of roles going for other data types of positions. So if you're interested in that, also check our website out.
It's almost like they teed up that question for you, didn't it? To talk about,
that's it,
come and work with us. It's perfect. That sounds good. As I say, conscious of time a little bit, but we'll keep going with a couple more final questions. Could you please explain more on why there is a size unevenness between C&T and the size sales ratio in the A/B test?
Yeah, I'll take that. So the plot I was showing with the actual control and test was just based on our historic sales that we used for the power calculation. So we don't have our results yet from the trial. But the idea being that our control group will just use the current business's sales ratios, and our test group will actually take our models ratios. And if they are more accurate, we'd expect to see the sell-through to be even across all the sizes. So we'd recommend, for example, on a very small size to send less of that, which means when you take your sales over your stock, your sell-through will go up. So what we'd like to see is actually an even sell-through across the sizes.
Perfect. Thanks very much. Question from Jitendra asking about how often you retrain your models. Is that something that you've had to, you know, really focus on in a, you know, proofs of concept? What are your thoughts in terms of retraining?
Yeah, it's an interesting question. So when we were looking at the backtesting, we were looking at training a model for 24 months prior to an actual launch, which is typically a month in itself. But then products don't all launch at the same time. So they might launch a little bit early or up to 30 days after their sort of scheduled launch date. So we backtested the model where we train it and then test on products that are going to launch within 30 days of its listed sort of date. And then for every upcoming launch, we're planning to sort of retrain the model at this point.
Perfect. Thank you very much. And then we'll take this last question. Sashwa basically said that they worked on similar challenge at Tesco's. At the time, they found it difficult. One of the challenges was to test the whole process. At each stage of the volume forecasting process or different sub-process, they couldn't be tested in isolation. And they were basically asking, you know, how have the team at Marks and Spencer's come across that? And, you know, if so, how have you tackled the problem?
Yeah, I can talk about the sort of allocation trial we're doing, and then maybe Martyna could comment on another similar trial we've got in Markdown. So for the allocation trial, we're just looking at the first 28 days of sale when a new product launches. So at that 28-day cutoff, we'll just look at what are our sales over the stock received up until that point. So that helps us calculate our metric of sell-through limited to that time window. So we're not looking at then the subsequent sort of replenishment and sales after that, going up to the markdown phase. We just focus on that initial allocation step. And then we're doing it in a sort of iterative way. So first, we're just looking at sales ratios. But if we then develop a solution on store percentages, we do that as a second step to test it. So we're not doing them at the same time.
Perfect, thank you. Martyna, anything to add?
Yeah, just very briefly. So the project I work on is markdown pricing optimization. We are in a reasonably comfortable, in a sense, situation that we are at the end of the product life. So there is not that much more that can possibly, affect what the product is about to do. In terms of what we measure, we look at the several metrics. I mean, the name of the game and the final KPI is profitability and revenue. So really increasing the profitability, but we need to keep an eye on things like an average discount, so, the shape of the average discount, how well we're selling through the stock, because you don't want to be writing off large volumes of stock. But I do agree with the comment around, the interconnectedness of different solutions and bearing in mind that you can't really test just one component in isolation. As we go more and more into, this end-to-end integrated data science applications, and also especially forecasting, which may touch different areas of the product lifecycle, is something that's, we're aware of the interactions and the challenges there.
Perfect. Thank you very much. Yeah, I guess as we just kind of draw things to a close then, I would definitely like to thank each of you individually. So Martyna, Mohammed and Darren, thank you for giving up your evening to come and share with us. And I do always mention it as well, it's not just obviously the time you've given up to come and join us today. There's clearly been a lot of thought and preparation gone into pulling the slides together and working out what you want to share with the community. So thank you massively for that. And I would also, as I say, like to give a big thank you to Marks and Spencer's. We definitely can't have become the community that we are without the support of some forward-thinking companies, and it's been great working with Marks and Spencer's throughout, and I'm really looking forward to meeting them on the day of the festival and seeing more from you in the future. So thank you, and thanks Marks and Spencer's. How have you enjoyed it all? Are you happy with the session?
Yeah, very much. Thank you very much. Fantastic session.
Amazing.
Really
Hopefully we get the chance to do this in real life at some point, and maybe even share a beer afterwards. But thank you to everyone that's joined us at home as well. It's always great to have you with us, coming and sharing the content, and I'll hopefully see you all soon. But thank you very much, and it's goodbye for now. See you soon.
Thank you.
Bye-bye.
Bye.
Bye.